Welcome to CW 5.3. Today we're going to be reviewing some log properties. So first, we're going to start with the sum and the difference property. Log, I'm going to use x as the base here. So log base x of a plus log base x of b, that's going to equal log base x of a times b. And then if you have log base x of a minus log base x of b, that's going to be log base x of a divided by b. And finally, we have the power rule here. These are the first ones we're going to talk about. You might recall this from your last algebra class. This is the most unique property of a log, is that if you have an exponent on the thing within the log, it can actually move around. So this n can shoot to the front as a coefficient, and if it's a coefficient, it's allowed to go back to the exponent. It's a pretty cool property about the log. So let's do a couple problems here. It says use a product rule to expand it. So we're going to write log base 4 of 7. I see a times, so write plus log base 4, 5. And you're done. You've expanded it. Next one, log, there's no base here, so for now let's leave it. 10 plus log of x. Now hopefully you remember that in a problem like this, if there's no base specified, the base is assumed to be 10. So for example, log base 10 of x equals log x. That's known as a common log, because 10 is a very common number to work with, in science especially. Now if the base is 10, let's fill that in here. That means it can actually be simplified further, because this thing on the left, right here, this thing is actually 1. And then we can just bring down the log, and we're done. Let's keep going. So next one, I see division, so I'm going to subtract minus log base 7x, circle. And this one, you see natural log. Remember that ln means natural log. I have ln e to the third minus natural log 7. Let's bring that 3 down. So 3 natural log e minus natural log 7. And hopefully you remember that this thing right there, that's 1. So it's 3 minus natural log 7. And if you're not sure how I did that, make a quick note here that natural log of e is equal to 1. And the reason that is because natural log, the base is assumed to be e. So if those match, of course it should be the number 1. Let's keep going. We're going to use the power rule again here. I'm going to move that 4. So 4 times log base 5 of 7. The root, you want to rewrite that as x to the 1/2. So now I have 1/2 natural log x. And this one, I'm actually going to move the 5 out first. So I have 5 log 4x. And then think of it as one big separation like this. Log 4 plus log x. That distributes to 5 log 4 plus 5 log x. So if you're really good at this, you can do this one kind of in your head. You want to be able to identify how many pieces there are. So there's one piece here, one piece here, and do the power rule in your head. So you have 2 log base b of x plus 1/2 log base b of y. Now for this one, this is tricky. Make sure you're able to identify each piece. So I see a cube root x on the top, a y to the 4th, And this is the part people struggle with. That 36, think of that as its own piece. So you want to separate it from the other variables there. So now we're going to write 1/3, oh, let's fix my pen, 1/3 log base 6 of x minus log base 6 of 36 minus 4 log base 6 y. You might be noticing that I put a minus on both of these. That's because they're both on the denominator. Things that are on the bottom should have a minus in front. Things on the top should have a plus in the front. Now we keep going. 1/3 log base 6x. 6 to the 2 is 36, so put minus 2. And there's our final answer. Now we can do the other way. We're going to combine them. So this would be log base 4 of 64, and that would reduce to 3. And this is the good one. The algebra is actually the easy part, because you literally just put them together and then you're done. Now we continue. So A, see if you can do it all in one shot. So log, that's the root of x, times x minus 1 to the 4th. And make it more clear, it might be easier to put a big bracket like that. Now B, natural log x plus 7 to the 3rd over x. And then the last one, log base b. Now for this I do it in pieces. I'm going to look at, this thing is positive, so I know that x to the 4th should be on the top. This thing is negative, so that 36 should be on the bottom. And the y is also negative, so that should also be on the bottom. So I'll make that root of y. And that's it. Now we go to the final two. This is the last property. So this is the base change property, or I call it change of base property. This is kind of the most unusual property, but it's helpful in particular instances, and this will be one of them. Log base a of b is equal to log b over log a. And it's helpful here because I can evaluate this log as this in any ordinary calculator. You don't need anything fancy. A regular calculator like you have in science could figure this out for you, and you're going to get 3.07. Which means if you plug that in, so 5 as the exponent, you will get 140. Of course, it won't be exact because we rounded this, but if you use the exact number, you would get exactly 140. So that's one use of this property. So make sure you box this thing right here. That's a very practical use. So a theoretical use, like for our class, is going to be a question like this, where we're multiplying. And if I know that property, what I can do is do something like this. I can split them. They might be thinking, well, that makes it even more messy because now I have twice as many logs. But let's do a couple more properties. 25 is 5 squared. 27 is 3 cubed. And now we're going to do the power rule. So that 2 is going to come down. That 3 is going to come down. And look at what happens here. Cross, 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 cross. The answer is 2 times 3, which is 6. Okay, so that was a crash course in all the log properties. Let me know if you have any questions, and I'll see you in class.